Good evening, guys. Am I audible?
Yes, sir.
Yes.
Okay. So let's wait for a few more minutes. Let others also join, then we'll get started. We'll get started, guys. So, lastly, we were doing motion in a straight line, right? Okay. So, we will do some problems based on them. We have already started few. Okay. In today's class, we'll do few more problems. And from the next class, I'll start the fourth chapter, that is motion in a plane. So even before I start, I would like to ask you, is there anyone who wants any topic that you want me to discuss? Is there any topic that you feel you are
Nothing,
struggling?
sir.
You're fine with everything? Okay, then we'll proceed with the remaining problems. So I hope you're able to see, right? So the last problem that we did was 13th. Sorry, 12th, I think. Now we'll continue with the remaining problems. Oh, sorry, I don't think we did this problem. Did we do this problem? Yeah, 10th we completed. 11th we did. 12th also we did that bus thing. So I think we need to start with the 13th one. Okay, so let's get started. So let's start with the 13th one. So ball is thrown upwards. Okay, its height varies with time as shown in the figure. If the acceleration due to gravity is 8 meters per second square, then what is the height to which the object has reached? Can you find that value of h, guys? So can someone give me an idea of how to solve this? Any idea? So read the question carefully. There is a ball that is thrown upwards. Its height varies with time as shown in the figure. The acceleration due to gravity is 1 minute. I'm getting many messages. Yeah. Tell me how to solve this. Guys, I know online means no one will speak, but no option. You have to. Tell me how to solve this. So they are expecting us to find this h. What is the value of this h? How to do this? So at least how to start? Tell me how to start. So ball is thrown upwards means, let's say its initial velocity is u. Okay. You're able to see on the x-axis that you have 1, 2, 7, and 8 seconds. 1 minute. Yes, you have this 1 to 8, 7 and 8 seconds. So what will this height correspond to? So what does this value represent? The point which I marked. Can I say it is a displacement of the particle in 7th second? Yes. Can I say this is the displacement of the particle in the 8th second? Can I say that?
Yes, sir.
Right? Similarly, what would this be? This would be the displacement of the particle in the 2nd second. This would be the displacement of the particle in the 1st second. Okay. So can I say h is nothing but s2 minus s1, and it is also equal to s7 minus s8. Observe. Is that right?
Yes, sir.
Right. So let's say the object is projected with initial velocity u. It is traveling under the influence of gravity in the downward direction. If that is the scenario, then what is going to be the formula for displacement of the particle in 2 seconds? So what is the displacement of the particle in nth second? This I have explained. U plus half into, or U plus A by 2 into 2n minus 1. Can you say that? Or what I can do here is, if to find this position, I'll calculate how much is the distance traveled by the object in 2 seconds. How much is the distance traveled by it? Ut minus half gt square. That is 4. Okay. Similarly, what is the displacement of the particle in 1 second? Ut minus half gt square. Okay. So what is s of 2 minus s of 1? That is going to be equal to half, or this thing, 2u minus 2g minus u minus g by 2. Is it right? Is this right?
Yes, sir.
Right. So if I simplify this, I'll get u minus 2g plus g by 2 is how much? Minus 2g plus g by 2 is how much? Minus 3g by 2. So it will be u minus 3g by 2. This is h. Let me call this as equation number 1. Similarly, I'll give you 2 minutes time. Find out what is the displacement of the particle in 7 seconds minus what is the displacement of the particle in 8 seconds, and tell me what is the value. Apply the same formula, ut plus half at square. U is u only. Time you have it in the bracket. Acceleration is minus g. Do it fast. Tell me. Did you all get this expression?
One second, sir.
Yes.
Yes, sir.
Okay, is this the expression? Now, from 1 and 2, I can conclude that u minus 3g by 2 is the same as minus u plus 15g by 2, which implies 2u is equal to 18g by 2. Is that right? So if I take g to be 10, so 18 into 5 is what is 2u. So u will be equal to 9 into 5, that is 45 meter per second. Okay. Once u is 45 meter per second, substitute it back in any one of the equations and try to find out the value of h and tell me. 1 minute, wait, 1 minute. Oh, sorry. Here in this problem, they have given acceleration due to gravity is 8. If that is the case, then this will be 4. 18 into 4 is 72. Okay, I'll come again. So if you observe, 2u will be equal to 18g by 2, or it is 18 into 4 divided by 2. It will go, 18 into 8 divided by 2. This will go 4 times. So 2u is equal to 18 into 4 is 72, which implies u is 36 meter per second. So when u is 36 meter per second, then you can find h by substituting u in this thing. So it will be minus 36 plus 15 into, what is the value of g? 8 divided by 2. So 60 minus 36 is going to be 24 meter per second. 24 meter. Is there an option? Yes. So did you guys understand the problem?
Yes, sir.
Okay. Moving on to the next one. Guys, do you have exam tomorrow?
No, sir.
No.
No.
And why is no one speaking? Only you're talking. What about others? Abhinav was speaking, right? Because
Yes,
you,
sir.
right?
Yes, sir.
Hariharan, Hariraghav, what about you guys? Shakti, Srinidhi, Shrikriti. Are you guys there, first of all?
So yes, sir.
Yes, sir.
Speak, okay? So I'm actually getting bored. I can't teach like this. If you guys speak only, I'll get many ideas. So be active, right? We'll get started. See, a body covered a distance of 5 meters along a semicircular path. The ratio of the distance to the displacement is simplest problem. So a particle has started here. It has covered a distance of how much value? 5 meters
5 meter.
in a semicircular path. Okay. Now, what is going to be the displacement? A ratio of the distance to the displacement. How to solve this?
We should find the length of the arc, sir.
Yes.
Sorry, sir,
What is the
the
length of the arc? What is the length of the arc?
Length of the arc is 5 meters,
Yeah.
sir.
Length of the arc is pi r. Is that right? Because half of the circumference of the circle. Right?
Yes, sir.
Yes, sir. We should find.
Yes. Pi r divided by 2r. Why 2r? Because when you go from A to B, this is the displacement. Am I right?
Yes, sir.
Yes,
Yes,
sir.
sir.
So how to solve this? Pi r divided by 2r. So r and r will get cancelled, which implies pi is how much? 22 by 7 divided by 2. Answer will be 11:7. So if you observe what is unwanted data in this problem, 5 meter, because the ratio of distance to displacement is independent of what is the value, what is the radius of the circle. You're able to understand? So answer is 11:7. This is the answer,
Yes.
right? So shall we proceed?
Yes, sir.
Right. This is another problem that I discussed yesterday. The velocity time graph of two bodies A and B are as shown. The acceleration A and B are in the ratio. So velocity time graph, what is the acceleration? For a velocity time graph, what is the acceleration? It is the slope. But what is slope? Slope is tan theta. Where theta is what? Theta is the angle made by the line with x-axis. Am I right?
Yes.
So what is acceleration of particle A? That is tan of what is the angle made by the line A with x-axis? It is 25 degrees. divided by acceleration of B is how much? What is the angle made by B with the x-axis? Concentrate and find it out. You need not think too much. It's very simple.
50 degrees.
That's right. Because 40 is the angle made with the y-axis. But I need this angle. It is 50 degrees. So tan 25 divided by tan 50 degrees is going to be the answer, which is this one. And the most commonly made mistake is most of them will choose this one, but that is wrong. Why should you not choose tan 40? Because that 40 is made with respect to the y-axis. Is it clear?
Yes, sir.
Good. So this is based on relative velocity, which I'll explain in the next class. This one you can try. So there is an object that is dropped from the top of a tower, covers a distance of 7 times x in the last second of its journey, where x is the distance covered by it in the first second. How much time does it take for the object to reach the ground? Can you guys try this? I'll give you the hint. Distance traveled by the object in n seconds is Sn is equal to u plus a by 2 into 2n minus 2. Where u is the initial velocity, a is the acceleration, n is the nth second. In nth second. Okay. Clearly, if you read the question, you will get the answer. Try it out. Any suggestions? You're trying?
One second, sir.
Yeah, right. Okay. Did you understand what I did?
Yes, sir.
Let's say the particle has taken n seconds to go from top to bottom. Distance traveled by the object in the nth second is equal to u plus a by 2. In the place of a, I substituted g into 2n minus 1. But since the object is dropped, when you see the word dropped, u is equal to 0. So when you put u is equal to 0, you get g by 2 into 2n minus 1, which I'll consider it as equation number 1. So what is S1? So this is the distance traveled by the object. By the way, this is the distance traveled by the object in the nth second. Distance traveled by the object in first second will be what? Again, u is 0. Acceleration due to gravity is g divided by 2 into, in the place of n, I substituted 1, so 2 minus 1, which will give me g by 2. And this g by 2 is what is x, right? Where x is the distance covered by the object in the first second. Okay, so S1 is x and Sn is 7x. But what is Sn? G by 2 into 2n minus 1 is equal to 7 times x, 7 times g by 2. So g by 2 will get cancelled. When you solve this, you will get n is equal to 4. So it is 4 seconds that the object has taken to cover the total distance. Eighteenth one. If the velocity of the particle is given as 180 minus 16x, the whole power half, okay, then its acceleration will be. So if velocity is given, how do you find the acceleration? If velocity is given, how to find the acceleration? Find dv by dt. So what is dv by dt here? Who can tell me? So it is 180 minus 16x, the whole power half, right?
Yes, sir.
So what will be the value? Derivative of 180 minus 6x, the whole power half, is half into 180 minus 6x, the whole power minus half, into d by dt of 180 minus 6x. What did I do here? Can someone tell me? What did I do here? I differentiated using chain. I use chain rule, basically. Is that right? Okay.
Okay.
So there's 16. There's not 6, there's 16. So it is half into 180 minus 16x, the whole power minus half, into d by dx, d by dt of 180 minus 16x. Tell me. Derivative of 180, 0, minus 16 into derivative of x is dx by dt. So half into 180 minus 16x, the whole power minus half, into minus 16 into, what is dx by dt, guys? Is it not velocity?
Yes, sir.
It is velocity, right? So this will be half into 180 minus 16x, the whole power minus half, into, so I'll write this minus 16 outside. 1 multiplied with minus 16 is minus 16, into what is v given? V is given as 180 minus 16x, the whole power half. Now what will happen to these two quantities? So
Yes,
180,
cancelled.
yes, they get cancelled. Hence, what I left out with, you're left out with minus 8 meter per second square. And this is what is going to be the required acceleration. So acceleration is minus 8 meter per second square. This is a good problem. I mark it as important. Okay. right? Please copy this. Okay, this one we'll do it later. So I'm searching for easy ones. So let's do from 21. So there is an object which is fired vertically upward. At half the maximum height, the velocity of the body is 10 meters per second. The maximum height raised by the body is. So you have a ground. There is a ball which is fired vertically upwards with speed u. Okay. And it has reached maximum height with a velocity equal to 0. Is that right? When it reaches the maximum height, velocity is 0. Let's say this is half the maximum height. So h max divided by 2 is this. So at this point, if you see the velocity at point 1, it is observed to be 10 meters per second. If that is the case, then what is the maximum height raised by the particle? So I'll give you hint. Don't think of anything outside equations of motion. So your job is to just think in terms of the basic equations of motion. So first, the question that you're supposed to ask is how many unknowns are there? How many unknowns are there? So what is not given in the question? What is that I have assumed? U. Initial velocity is not given. And our job is to find the maximum height. Is that right? When this is the scenario, right? So I need to find what is H max in terms of with the data that is given H max divided by 2. Will I be able to find a relation between V1 and U by applying the formula V square minus U square is equal to 2AS?
Yes.
So for V square, V1 square minus U square is equal to 2 into acceleration due to gravity is minus G into displacement of the particle is H max divided by 2. Am I right?
Yes, sir.
Okay. So V1 square is 100 minus U square is equal to minus 2G into H max divided by 2. 2 and 2 will get cancelled. So you will be having minus G into H max. Let this be equation number 1. Similarly, for second case, applying V square minus U square is equal to 2AS, right? For the total journey, if I call this as H max, right? So when the object has gone from point A to point C, so this is between point A and B, and this is between A and C. So when the object has gone from A to C, then I can say 0 square minus u square is equal to 2 into acceleration due to gravity is still minus g, and displacement of the particle this time is h max. Am I clear? So what I can do here is, in the first equation, I'll do a small modification. From this, I'll say u square is equal to 100 plus g into h max. This I'll take it as 1. This I'll take it as 2. I'll use 1 and 2 so that I get minus of 100 plus g into h max is equal to minus 2g into h max. So minus and minus will get cancelled. 100 will be equal to g into h max. If I take g to be 10, then what will h max come out to be? It will come out to be 10. So answer is 10 meters. Guys, am I clear with this? Is the logic clear?
Yes, sir.
Please make a note of this. Shall I proceed?
Yes, sir.
There is also a good problem. So break the scenario and try to analyze. There is a metro train that starts from rest and in 5 seconds achieves 108 kilometers per hour. After that, it moves with a constant velocity and comes to rest after traveling 45 meters with a uniform retardation. If the total distance traveled is 395 meters, then the total time of travel is how much? Any suggestions, any ideas that you would like to share with me? Listen, when you draw for these kind of problems, no, the first thing is I would suggest you to draw a velocity diagram. Okay, So an object starts from rest and in 5 seconds achieves 108 km/h, means the object has got accelerated. So how much is this time? So this is 5 seconds. And what is the speed attained by it? It is 108 km/h. Is that right? After that, it moves with a constant velocity. Okay, we don't know for how much time. Let's say it travels till time t with a constant velocity of how much value? That value is definitely going to be 108 km/h. After that, it comes to rest by traveling a distance of 45 meters with uniform retardation. So retardation means velocity should decrease with respect to time. So if I take this as t1 and this as t2, right? It has traveled with decreasing velocity and it has come to rest. Okay. So what are the given data? Total distance is 395 meters. Is that right? So for a velocity time graph, how will you find the distance? So with respect to a velocity time graph, what is distance or displacement? How to find it? By finding the area under velocity time graph. Is that right? Is that right?
Yes, sir.
Right. So we need to find the total area. If I take this first area, which I'll call it as A1, so what is going to be the value of A1? It forms a triangle. So half into base into height. So 108 km/h is how many meter per second? It is 108 into, how to convert km/h to meter per second? You should multiply it with 5 by 18. So it gets cancelled like this. It goes 6 times. It will be 30 meter per second. Okay, just a minute. I'm getting a call. You substitute that value there and calculate the value of A1 and tell me. So if you substitute A1 here, it is going to be 30, it is going to be 15, it will be 75 meter. So here the object is covering a distance of 75 meters. Right. Now, how to find this area, which I'll call it as A2. So how do I find A2? A2, what shape does it take? To find A2, what shape are you able to see? It is the area of the rectangle. So for rectangle, how much is this distance going to be? It will be T1 minus 5. And how much is the height going to be? It will be 30. So T1 minus 5 into 30 will give you area 2. Right? That is these many meters. And A3 is already given to you. What is A3? So A3 is half into base. So how much is this distance, guys? It will be T2 minus T1. So T2 minus T1 into, the height is still going to be 30 meters per second. So it is going to be 15 into T2 minus T1. So this is A3. But remember, the distance covered with retardation is given to you, that is 45 meters. Right? So A3 is 45 meters, which implies T2 minus T1 is T2 minus T1 is 3 seconds. Okay, T2 minus T1 is 3 seconds, which implies T1 is equal to T1 is equal to or I can say T2 is equal to T1 plus 3. Right? T2 is equal to T1 plus 3. Okay, having said this, now there is another important information given. The total distance traveled by the particle is going to be A1 plus A2 plus A3 is 395 meters. Right, 395 meters. So A1 plus A2 plus A3 is 395. But what is A1? It is 75. Plus what is A2? 30 T1 minus 150. Plus what is A3? A3 is 45. That is already given to us, 395. So 1 minute time, find out the value of T1 and tell me. So what is the answer, Resh? So 75 plus 45 is
Sir, 15, sir.
T1 is how much?
15.
15 seconds, sir. Okay.
Yeah.
T1 is 15 seconds means T2 will be 15 plus 3, which will be 18 seconds. So the total time the object has traveled or the train has traveled is 18 seconds. So actually don't have 18, it's coming out to 17.2. That will be the right answer. Let me check. Yeah, 17.2. Is the method clear to everyone? This is a new thing that you have learned today. Last class you asked me about the graphs. The last week you people asked me about the graphs, right? So this is one of the applications of how to draw the graph on your own and then solve the problem. Okay, make a note of this. So copy it. Right? Shall we move on to the next one?
Sir, yes, sir.
Try this. A car moving on a straight road with a speed of 144 km per second is brought to a stop within 200 meters. How long does it take for the car to stop? Try it out. So I'll tell you, in this problem, there are two unknowns. What are the two unknowns? Any idea? One is the retardation and one is the time. And one is the time. So U is equal to 144 kilometer per hour. So U is how much? 144 into 5 divided by 80. How much will this give you? (40 meters per second). Right? So displacement of the object is 200 meters. Okay. So V square minus U square is equal to 2AS. V is 0 because the object has come to rest. Minus U square is 40 square, that is 1600, is equal to 2 into acceleration of the object is what you need to find, and the displacement of the object is 200, which implies A is equal to minus 400 meter per second square. Sorry, minus 4 meter per second square. Four or 8? 4 only. Minus 4 meter per second square. So how long does it take for the car to stop? V is equal to U plus AT. V is again 0. What is U? U is 40 plus acceleration of the object is minus 4 into time. So time will be 10 seconds. So it takes a total of 10 seconds for the object to come to rest. Right? So we'll do two last problems and then wind up.
Okay.
Try them. Yeah. A body is projected vertically upwards with a velocity of 10 meters per second. It reaches a maximum vertical height h in time t. In t by 2, what is the height covered by the same particle? So the particle is projected upwards with a speed of 10 meters per second. It reaches a maximum vertical height h in time t. In time t by 2, h dash would have been what in the same time t by 2. Okay. So how to solve this? So first, let's try to find out what is the t by 2. Okay. So for the particle to reach maximum height, what would have happened? V will be equal to U plus AT. U is 0. Sorry, V is 0. U is 10 minus acceleration due to gravity is 10 into time is t. So from this I will get t is equal to From this, I will get t is equal to 1 second. So it takes 1 second for the particle to reach the maximum height. Right? So in half second, what would have been the distance traveled by the particle? So for that, I will apply h dash is equal to ut plus half at square. U is 10 into time is 1 by 2 minus 5 into t square, that is 1 by 4. So 5 minus 5 by 4 is 15 by 4 meter. Okay, 15 by 4 meter. But for that, I need to know how is it related to h. So for h, I will apply the formula ut plus half at square. U is 10, displacement is 1, plus half into acceleration is minus 10 into 1 square. So 10 minus 5, it will be 5. So it will be 3 into 5 divided by 4. So it will be 3h divided by 4. It would have traveled 3/4 of the height. Okay. And okay, I don't want this one. Okay, do this one and we'll wind up. Which statement can be impossible case in 1 or 2 dimension? A body has 0 velocity and still be accelerating. Is it right or wrong? An object can have 0 velocity and still be accelerating. Yes, it can happen. Yesterday, I gave you an example. None of these, no. An object is increasing in speed as its acceleration decreases. Is that possible? Why is no one talking?
Sir, 1 minute.
Sorry? 1 minute.
Sir, I'm reading.
Read it. So what is the answer?
Sir, A, sir.
Read the question. Which statement can be impossible case? A is not impossible because when you project the body upwards, at the highest point, velocity is 0, but acceleration is still existing.
Oh,
So A
okay.
is right one. Yes.
Sir, I think D, sir.
Velocity of the object reverses direction when acceleration is constant. That is also possible, right? Because when you project a body upwards, what happens is the object's velocity is in this direction. When it is coming down, the object's velocity is in the opposite direction. But what is the acceleration here?
Acceleration increases, right, sir? While coming down.
No, acceleration is still g because the object is traveling under the influence of gravity.
Oh, okay, okay.
So this is also right. Think.
Sir, acceleration can't decrease, sir. So, see,
My knowledge is this should be the answer. Yes. Okay. So let me see. Okay. So remaining problems, I'm leaving it to you. Next week, I'll be starting the vectors chapter and we'll be having an extended class. Okay. So next Thursday and Friday, I'll be starting vectors, that is motion in a plane, which is very, very, very important. Okay. And I'll be explaining the relative velocity concept also once I complete vectors. Is it clear? So keep practicing till then. Yes. So any other doubts?
No
sir,
doubt.
no.
Sir.
Okay, then we'll wind up.
Thank you, sir.
Thank
Yes.
you.